Good evening, everyone. I'm Professor Andrei Zvelindovsky, Head of School of Mathematics and Physics in the University of Lincoln. Very warm welcome everyone who came to this math chat, our first math chat which we organize online in the University of Lincoln. Again, very warm welcome to everyone who came. Just to tell how our chat runs. After a short introduction, you will hear a short presentation followed by questions which you can type below in a live chat of our YouTube channel, and we'll try, our speaker will try to answer them the best, and later you can also rewatch this video on YouTube at any moment of time. So very warm welcome everyone who came, who watches us online, and our special guest today, Dr. Snezana Lawrence. Welcome, Snezana, here. We meet each other using this video link. So in times of pandemic, we developed these new tools to communicate. Even we cannot come in the same place, but we still can chat. Just a few words about Snezana. Snezana is originally from Yugoslavia, from Serbia, and then she first studied there descriptive geometry in the University of Belgrade before moving to United Kingdom in early 90s. She earned her PhD also on the topic geometry applied to architecture and Freemasonry in 19th century England from the Open University here in United Kingdom. Snezana spent some time in secondary education in school, where she also won Gatsby Teachers Fellowship in mathematics in that time. Subsequently, Snezana moved to higher education and been working as senior lecturer in a series of English universities. She is currently chair of History and Pedagogy of Mathematics International Study Group, which is an affiliate of the International Mathematics Union. And also she is diversity champion of the Institute of Mathematics and its application here in the United Kingdom. Snezana is also author of the books, and this is one of the reasons why we asked Snezana to come here. Just before New Year, I actually bought her book, this one you probably can see, and that I bought just before New Year as present for myself. And of course, book has a nice title, A New Year's Present from a Mathematician. I just started reading the book, and then we've been very happy that Snezana agreed to come here and chat with us about her book and some interesting stuff which mathematics offers everyone. Floor to you, Snezana. Very warm welcome in our our mathematics chat.
Thank you very much. Thank you very much, Andrei. Absolutely delighted to be invited, and really great thanks to you for inviting me to open up this math chat, and also to Sergei, who has shown great patience behind the screen to work through all the technical problems. So I'm going to share my slides, and this is the point where hopefully everything works now. Okay, so I'm going to talk to you really a little bit about this book. I mean, the starting point for this chat is the book that I've done recently, which was, as Andrei said, the New Year's Present from a Mathematician. But the focus that I'm going to take from that book is on shapes, space, and sort of the nature of matter from Kepler to Newton and back. And it's also that is the real focus. But actually, there is a whole space of things there behind that we can touch upon. First of all, I'll say where the motivation to do this talk comes from. So it will be about that. It will be about a few people from that feature in the book. It will be also about various threads that join all the chapters together. And then I will talk a little bit about what keeps inspiring me to do more research and more writing, particularly, obviously, in history of mathematics, but also further on in mathematics education, and currently in sort of teaching mathematics at Middlesex University. So the motivation. Well, some years ago, in 2013, there was one of the conferences. This was a series of conferences organized by mainly by Brendan Lava, who is a reader of philosophy of mathematics at the University of Hertfordshire, and he got lots of people from mathematics. Mathematical community, there sort of quite a lot of diverse people represented everything that sort of mathematicians do. So there were people who were in working for the government, academics, students, PhD students. I remember we even had sixth form students, and we had lots of just really plain mathematicians, and we had some philosophers of mathematics. And what surprised me, and it surprised other people as well, was that we were talking about different cultures in mathematics, different cultures that you can see in different countries, and also different cultures that you can see in different historical eras that you can sort of study and gain some knowledge of. And the sort of diversity of different practices and in terms of how people look at mathematics and how people see mathematicians was quite considerable. But one thing was obviously one thing was obviously puzzling one of the speakers, and the speaker asked the audience to raise their hand if they were a mathematician. And out of about 50 participants, 3 people did so. And I admit I was really, really surprised at that, because these were all people, apart from the sixth formers, these were all people who were making a livelihood, out of doing some type of mathematics. And then in June the next year, similar thing happened. I repeated this experiment at the Festival of Mathematics, which was organized by the Institute of Mathematics and its Applications at the University of Manchester. I believe it was the 50th anniversary of the Institute. And there was even a larger group of people there. But these were people, we had absolutely no A-level students. I don't think we had any PhD students. We had many more government mathematicians, we had people from industry, we had academics, quite senior people. And when I asked how many people see themselves as mathematicians, 2 people raised their hands. And this was really a motivation to start looking at why do people believe that even when they're doing mathematics, they may not consider themselves mathematicians. And there are many more, anecdotes that I've collected on the way from there, and then I started actually looking at the literature that people have written or described similar sort of events from other periods, and this really was the starting point. I wanted to see what is it that mathematicians do, how can you identify a mathematician. And apart from the sort of humble view of oneself that mathematicians usually obviously have, according to these 2 events, what else can we say? What is it that mathematicians sort of focus on? So I also teach, for example, I teach on one of the modules that at Middlesex, I teach a brief on mathematics in society. And until recently, I must say, this has changed actually during the pandemic. Until recently, when you Googled mathematicians or most famous mathematicians, this, for example, would have been one of the posters or images or illustrations that comes about. So the views of mathematicians, although we know they're not all, white, dead men, there wasn't a great diversity of that available publicly. It has actually changed. I was surprised because I've looked recently on Google and I've seen many more different images. So that has changed. That is a good thing about, I suppose, people doing research and looking at things and particularly this particular issue really has come up again and again recently in mathematics education at all levels. So mathematicians are not all men and they're not all dead. Another view I wanted to present to you to sort of contemplate upon a little bit is people often see mathematics as very dry, as sometimes sort of dead. So the metaphor of a sand or a dune or desert comes to mind very often. But even those people who have actually been to deserts know that, if anything, deserts are really one of the most intriguing places one can find themselves. And so this is one of the metaphors that I used in the book, and I use quite a lot actually in mathematics education. It is an unknown place for most people, and mathematics has developed enormously, particularly since the 19th century. So unless you are doing, unless you are a sort of a very general kind of mathematics teacher and you sort of know quite a lot of very shallow kind of amounts of stuff of mathematics, if you're actually concentrating, if you're a research mathematician or a mathematician in industry concentrating on one particular issue, you're going to focus on that. So you're not going to see necessarily everything around you. But when you are entering as a student that mathematical landscape, that everything seems so strange and deserted, it is really important to sort of take some lessons from, for example, people that live in a desert. So how to survive, how to nurture the good moments, sort of drops of wisdom, as if it was drops of water as you go on your journey, and how to plot for yourself the map of mathematics that you may navigate on your journey, mathematical journey, as you learn more about it. So, a very brief account of the timeline. Although I said that I'm concentrating on from Kepler to Newton and back, the timeline includes quite a lot more. So I start my journey within this book from the Grand Library of Alexandria, and Euclid of Alexandria and his most famous treatise, The Elements, which was written or compiled around 300 BC. And I finish with Alexander Grothendieck, French mathematician who is one of the creators of modern algebraic geometry, who really died only very recently. So it spans majority of our known sort of history of mathematics. And within that huge timeline, there are things that I concentrate upon, and there are sort of these various threads. So I'll mention some of them. So I said it is about shapes, space, and matter. So let's see how that looks with Newton. So Newton appears actually in the first chapter, because another thread that I draw through the book is a chronological order of birthdays. So it's not the chronological order of when people, the eras, historical eras, it is the birthdays. And this one I picked because it was actually quite controversial, and it has been controversial ever since, since I mentioned it. That I say that, for example, he was born on the 4th of January 1643, but of course this was the period when Gregorian and Julian calendar were sort of being changed. And in England at the time, he was still born actually in according to the Julian calendar in 1642. But everywhere else in Europe, the calendar was already switched. So everywhere else in Europe, it would have been considered 4th of January 1643. Now, this wouldn't have been so important, I suppose, apart from, of course, how do you sort of say? In fact, I was told a couple of times, everyone says his birthday is on Christmas Day, but in fact, Newton spent quite a lot of his working life looking at the accuracy of calendars. In fact, he believed that the calendars, as we look at them, or the calendar that was in use at the time, the historical calendar, the calendar according to which you can sort of trace the calendar through the Bible, was inaccurate. He was quite a heretic, really, but not openly. Pretty, he knew that what he was saying and doing was not necessarily something that people would look lightly at the time. And he wrote a whole sort of huge volume about actually tracing the history of the world through his account, through his new calculations of the calendar. And that was obviously that he based that on his various studies, including astronomy and his studies of the Bible. That obviously was something that was really occupying him to the very end of his life, and it was something that was very important. And it was actually the center of not only that, but it was center of his interest in how the world works. How has the time started, and how does the time sort of go on? In fact, actually, one of his proteges, his successor, who came after him at the University of Cambridge, William Whiston, was a little bit more open about these things, but he got sacked for the particular that reason that he actually spoke about it openly. Although he actually contributed quite a lot to the longitude commission. Okay, so why I chose Newton? Newton I chose because, not only because I, by accident, sort of, we can sort of look at it, I sort of considered at that time, when I wrote this book in 2018 and 19, that his birthday could be considered to be on the 4th of January. But because of how complex a personality he was, he really inspired a huge number of people to look at nature differently, to look at the nature of matter, and to look at the nature of what can mathematics shows us about the world in a completely different way. And yet he had very few, or as far as I could find, perhaps one friend in all his life who he considered an intimate friend. And as a child, he was actually quite troubled. And that also was one of the things that I was taken by, that he had these deep questions, but he managed to get out of all of these difficulties in his life through application to trying to find the matter, the heart of the matter, the truth as he saw it, through the study of, all of those things, shapes, space and matter, really. And of course, we know now that his writing on alchemy it was much, much larger than any of his writing on mathematics, for example. Okay, one of the quotes that I wanted to show you was this one, his thoughts on sort of the nature of matter and on the nature of life. So he gives this, he says this: it seems to have been an ancient opinion that matter depends upon a deity for its laws of motion as well as for its existence. These are passive laws, and to affirm that there are no other is to speak against experience. For we find in ourselves a power of moving our bodies by our thought. Life and will are active principles by which we move our bodies, and thence arise other laws of motion unknown to us. And since all matter duly formed is attended with signs of life, and all things are framed with perfect art and wisdom, and nature does nothing in vain, if there be a universal life, and all space be the sensorium of thinking being, who by immediate presence perceives all things in it, as that which thinks in us perceives their pictures in the brain, these laws of motion arising from life or will may be of universal extent. As I said, he was quite wise, really, not to say all of these things in public, and I think this is still very much the case, that sometimes saying things in public will, there is a tendency to simplify them, and things are not, of course, simple at all. About shapes, Newton, for example, says extension was not nothing. This is my this is not a quote. I'm paraphrasing Newton here. And the empty space was divided up into an innumerable amount of really existing but invisible extended parts, all of which had the characteristics of mathematical figures. So he saw sort of this empty space not as just empty space, but there were invisible shapes within that space which manifested themselves at certain points. And then the other foci of my talk is, of course, Kepler, a fantastic scientist, mathematician, and one who gives us, he studied diligently several sort of things within his lifetime. And obviously we have Kepler's laws of motion. But one of the things that I picked him up for, to look more into his life, was this present that he made for his friend. And his friend was also his patron when he lived in Prague. And this picture of Kepler walking around Prague, which was becoming covered in snow, to me really resonated personally, because my family, my siblings, various periods of their lives spent in Prague, and obviously I went and visited them, and I still go and visit when I can, obviously not in the last 2 years. And I could just imagine the sort of romantic idea that he had at that time. So his friend, his patron, Baron Wackenfels, gave him something for his birthday, and Johannes Kepler wanted to return the favor. So what could he give him? And so what he did was look at these snowflakes and did a mathematical study of them. And that study of snowflakes, from that time, he actually published it in later on. still became something that, a thread that you can trace up to all the way up to 2010. So Kepler was already an ultimate expert on starry and perfect shapes, and he studied on snowflakes while it began there in Prague on that very starry and snowy night in Prague, turned into a generalization of a theory that he developed while trying to show why snowflakes are hexagonal. And he looked at how spheres pack in three-dimensional space. And so, for example, he said that hexagonal shapes are the most efficient way of covering a plane, and then looked at also how shapes, three-dimensional shapes, would fill the space, three-dimensional space. So from that particular story, there were other stories. There was a story about Maria Gatana Anyasi, who I very much liked and learned about from a colleague, and then sort of looked a little bit more into her work. What particularly was important for me in her work was that she found, well, there were two points actually. One is that she found the importance of mathematics to be in training the mind to concentrate and training the mind to one matter. And she found that of incredible importance, and also wrote about the importance of education for women. But also there's another point about the view of women in mathematics, and that is not necessarily a modern topic, because it really was even then a point of interest. So, for example, she became the first woman to be given a chair in mathematics. She never actually took it, but also she was studying this curve, which was already known, and the curve was called La Versiera. It was actually named by another mathematician, an Italian mathematician, and she described that curve in her treatise, which also described Newton's mathematics. And in English, this curve became known as the witch of Anyasi through an error, really. And that particular sort of type of error, I thought was quite an important indication of the women who do mathematics. Going back to the friendships, I think one of the stories I really particularly like to explore, and I still follow how things in that particular department develop, is the story of Nicholas Burbaki. And those of you who know a little bit about the history of mathematics would know that this is a fictitious mathematician who friends invented because they wanted to keep working without being shamed and blamed because they were from different parts of Europe during the Second World War. And so rather than do it openly, they sort of created this, they created this kind of secret society of mathematicians and published under one name. And actually, that I've seen the office in the École Normale in Paris, and next time I will go and look at the office again and say hello, whoever sits there. So I'm not going to stay too long because I want to go a little bit more. So I want to really bring some different threads together. So those views of mathematics, those two episodes when people said, didn't want to name themselves as mathematician, led me to do another sort of piece of research for another paper. It doesn't really appear in full length in this book. How high stake mathematics is. It really is high stake. And that has positive and negative effects on the practice. And it has actually positive and negative effects on people who want to join the community, who want to become mathematicians. But if you look at, if you zoom in, as it were, into different periods, and one of the aspects, one of the methods I applied when I was doing this research was to imagine myself looking at this mathematician that I've chosen as if they were working in their room or sitting or reading or doing something, and I would sort of be coming from another room, open the door a little and look at how and try to imagine what they were doing. And I was actually surprised by doing sort of research on all these different people in different eras and different cultures, how different they were and how different motivations and different types of mathematics they did. But there were obviously common threads, which I tried to sort of bring together about the nature of mathematics, about this search to understand the world, about the communications and processes of sharing knowledge, so about the language of mathematics that people developed through the centuries, and are able to share actually, throughout that whole huge period. Imagine other languages sort of get born and develop and then die, but mathematics still somehow we still can just about work out what people thought if we carefully look at it. And about the people I particularly liked this personal and group kind of understanding of generosity of spirit in terms of intellectual real generosity, of being able, of being important, how important it is to share what you know, and to encourage others to share, so that in that discussion continues continually through the centuries, so people can work out what is going on in the world. And one of the things I also liked was this nothing of which Kepler spoke, because his friend said that he doesn't need anything for presents. So Kepler said, okay, this little treatise is dedicated to the lover of nothing. And that sort of really a sense of looking at things mathematical and not being able to really define them, and sort of ether of the change constantly changes through the centuries. Okay, I think that's it. I think I've done what I wanted to talk about. There is obviously much more there, but I think it would be unwise for me to continue talking if we're going to have a little chat.
Thank you very much, Snezana, for your presentation. And now we can chat, and everyone who is watching us can type a question below in the live chat, and then we can kind of ask questions related to this presentation, or if anyone already read this book, also about that. And perhaps I would like actually to ask also a question. You mentioned these shapes, which also Newton thought that there's space made like with shapes, and it kind of reminds that the idea of shapes also was coming from Greeks, and you mentioned briefly Greeks in your presentation. From your kind of view, how much Newton kind of took in these shapes from Greeks? How much that idea changed? What was kind of, how did it kind of evolve, so to say?
Yes. So he was a great student of mathematics. So luckily, due to actually digital technology, we can see his notebooks, and we can study quite in detail. mathematical notebooks in the, for example, Cambridge University Library. But also there is this fantastic project which Robert Iliff has been heading for, I would say, goes now for it's definitely more than a decade, probably about 15 years. He is now at the University of Oxford. If you look at Google, it's called Newton Project, and it's not only the sort of original documents, but all the text has been normalized, so it has been retyped. So if you look at the things that he had in his notebooks, he studied a lot actually of modern geometry as well. He was aware of quite a lot. And actually, one of the things that I found funny was when the pandemic started, not the pandemic, I didn't find pandemic at all funny, but when the pandemic started, people would then ask, sort of comparing it to the plague. And obviously, Newton spent his, the plague years, he went from Cambridge back to his home. And during that period, he really started putting together the theory of calculus. So it was an incredibly important time in his life, and obviously in the history of mathematics. And it was quite funny to look at how people were saying that, look, this is a good opportunity. We can go and do all these important things, but obviously things don't work that way. But yes, so he knew quite a lot of the history of mathematics. What I was interested in was his study of the Dutch masters. That was really quite interesting for me. I didn't know that he would would have had those obviously books, but he did. He had access to the works of the Dutch sort of really quite applied mathematicians, and looked at the kinematic sort of description of curves, which for me was quite interesting. So that was something that is visible from his notebooks. I'm just going to try to find the chat so I can see if there are any.
Oh, yeah. There is question here.
Okay.
There is question from Team Play. Where do these portraits of mathematicians come from, and why most of people think they are real? These portraits, real representations of people.
Oh, yeah, that's right. Yeah, that's quite a good question, actually. So some of the pictures come from, some of the pictures. Well, I think most of these pictures actually come from people who drew the mathematicians afterwards. But actually, Newton, I must say, Newton's portrait looks very looks, really quite what do you call it? Realistic to me. It was drawn after a portrait which was done of Newton. So during his life. So it's probably not exactly the same, but it does look, to me, it looks pretty realistic. And obviously it's without, I chose it because it is without the, what do you call it?
Wig.
The wig, yes. And I think people wouldn't have worn wigs all the time. They would have worn it once, going out, I don't know, for graduation, probably. So this looked very realistic.
I see a question from Jack Martin, who is asking, who invented calculus, Leibniz or Newton?
Okay, I think I'm going to leave that one. There's about, I don't know, I know about 50 books written on that, so I'm not going to say it. This is the thing, you can't really say one or the other. I think it's both, and they complement each other really in different ways. It's very difficult to reconstruct. Sometimes things are much easier to reconstruct. This is not so easy to reconstruct because there was, there were communications and talking between people and so on. And actually what they did wasn't exactly the same. So they looked at it from different perspectives. But quite a lot of people think it was either Newton and, quite a lot of other people think it was Leibniz. Two of them had a huge falling out over it, obviously, and these things happen. I mean, it does happen often between people who are interested in the same thing, I think. I looked recently, because we're taking students soon to the British Museum, for example, and I looked at the old British Library Round Room, which is in the middle of the British Museum. Now, there were two designs for that, and two men claimed the design for it. They're actually quite different, but what came is sort of somewhere in between the two, more one than the other, much more one, which is actually the Italian designer, I forget now his name. But yes, it's very difficult to sort of, in these intellectual matters, it's very difficult unless you have the concrete proof.
Thank you. I wanted also to ask kind of a related question, not really about calculus, but the Leibniz and Newton. What I find when we talk about people from the past, we often put them a kind of in modern clothes. Like they live now, and you say in your book, and actually I know you also have interest in that in another book. You kind of discuss about how Leibniz and Newton were thinking about a place of God who would kind of so to say help them in all this their construction of the world round. So can you just comment on this? Because in modern, when we talk nowadays to students, we hardly tell them that these two people were deeply religious, and God played a lot of in their study.
Yes, exactly. Yes, I think that. Yes, I mean, I often do say that, but not in a way you should believe in God and this is what it is. But if you look at the history of mathematics, and if you look at quite a lot, all the way up to the 19th century, quite a lot of mathematicians were also theologians, or they were even priests of some kind, and that is because there is this overlap, looking at trying to work out how the world works is not really a simple task. And having two kind of, and the two really give you the two sort of ways of trying to work out, give you some kind of methods that overlap in certain areas. They overlap in metaphysics. Because certain things we cannot know yet. I mean, you are an astronomer, yes,
a physicist.
But you do quite a lot of talking about astronomy. And
yes,
stuff.
yes.
So there isn't everything we can tell, about the nature of space and time, and metaphysics obviously deals with that. And I think there's actually a fantastic book I recommend by Penrose. It's a fantasy. Is it fashion fantasy and I can't remember. It is about that kind of thing, where you have to actually allow yourself to look at things that maybe you can't ever, you're aware that you will never find out the answer to. And theology, helps in that respect, I think.
There are more questions now arriving, and for instance, there is a question from Charles Leeham Green who say, do you see evidence of Newton's heretical acceptance of Arianism in the general scholium of the second edition of the Principia?
I must say I haven't looked at it, so I can't tell. But yes, but I mean, he was not, he was not really. This is the question. How do you define a heretic? At the time, he probably, if he made his, for example, work on alchemy public, and his beliefs on Trinity, and his beliefs actually on the accuracy of the Bible, which is a book which got published soon after he died. that probably would mean that he would have been made. But by then already, people weren't considering that as a matter for which you would be burnt at the stake, at least. In Kepler's time, people were still burnt at the stake for that. So Kepler, famous stories about Kepler's mother, who he managed to save, who was accused of witchcraft, and he managed to save her from actually the fate, which I wouldn't imagine there were that many cases where people actually managed to save the people who were accused of witchcraft.
I see another question, or a kind of a discussion from Alexander Vasilyev. Does it really matter who invented calculus, Newton, Leibniz? Does that really affect how we perform differentiation?
Yeah, well, I think it does matter, actually. It doesn't matter who. It matters for us to know as much as we can know about the historical detail, because it is intellectual kind of history. But you wouldn't sort of say, does it matter who won the war? Or of course it matters. It matters what happened. So it matters who did what. But in that respect, but actually that is for me less important, who invented, it's like yes or no. That is really not as much important to me. For me, it is important to see the method by which people look at things, because only through that you can actually understand something of the nature of what is going on in that particular type, thing that you're doing with mathematics, because we have a tendency to just do what we learn, and what we learn is skipping, centuries, and that, centuries to be able to sort of say this is, how you calculate it. And also, there is a lot of there to sort of talk about in maths education. We expect, for example, students to tell us, we show them something, how it works, this is how it works, and now, give me in 10 minutes, I want the answer to this. People took 5 centuries to work it out. And there are lots of lessons, little and big, that I think are worthwhile, recording. You have to really be able to record that. You shouldn't, that is my firm belief.
Thank you. And just kind of when this discussion, who did Leibniz and Newton, I think what you say is actually important. Still look how it was all going, right? So it's not like to give prize, okay, Leibniz get first prize, Newton second, but actually look how it worked. And what often we find that there is a little bit of seems tendency to simplify history, and it just make, okay, Newton did this and Einstein did that, and at the end seems people think that everything was done by 2-3 people in whole centuries, while in reality there were zillions of people, and some names survived, majority waned kind of and disappeared. And without actually looking how they work together, who kind of spoke to whom and communicated, I think, we cannot really quite understand how this mathematics and beauty developed.
Yes.
Right. So there was also another question from Charles Leeham Green. Something looks kind of complicated. Do you believe in Newton's proof that an oval cannot be rectified algebraically?
Again, I didn't see that, so I can't tell.
I think when Charles visits us in Lincoln, we will ask him those questions to answer.
Shall I go back? I'll just go back one quick, because it's now in my mind. That talking about sort of historical detail, knowing how things developed. But there are lots of sort of, obviously for just historical reasons, it is really important to know all that. It is important to record history, of course. I mean, I don't think there is one person in the world, well, maybe there are a couple of people who would say history is not important. But, you have to know, how things worked. But also, we see things in our way. You know, our life is different to a life. You know, my life is different to a woman who probably sat in this. I mean, I live in a house which is, you know, from the beginning of the 19th century. So all these people, and you know, of either gender, who lived in this house and sat perhaps in this same, you know, they saw the world in a different way. And it's quite important for me to be able to look at the detail of what they wrote or did in order to, if I want to understand their viewpoint. Otherwise, you know, I have a tendency just to see what I see.
And other, as you say about you know, the difference in century, for instance, you mentioned that Newton was doing quite a lot of alchemy, but somehow, you know, if you talk to people or talk to students, almost nobody will know that he was doing that. And in your book, you mentioned like a search of Holy Grail, kind of.
He was really quite obsessed about these things, you know. But that's another point. So you look at some of his writing, some of it about things like that, you know, which is sort of really quite occult. You really don't expect, you know. So some of it you don't really even expect from an intelligent person. Yet, obviously, he was a genius. And I think it is important to preserve even those things, because it does show that, you know, he was a human. So he didn't have only fantastically genius, you know, unbelievably clever thoughts. He had thoughts which were mistakes, or he had thoughts which were really quite weird and no one else wants to know. You know, I mean, I don't really even want to go there. I think you need to ask Rabbi Lev to tell you about that, because some of the things, you know, he discovered are quite, yeah, you wouldn't really want to talk about. So I think it is actually important to sort of see people like that, rather than this monolithic, you know, ideal person who did everything just right and clever and never went on a sort of blind alley.
Mm. And when also in your discussion, it was briefly mentioned that Newton seems had just one friend, you say.
Yeah.
And he lived quite a long life and no friends.
Yes, that's right. Yes, yeah. Well, not very far from Lincoln, actually.
Yes, in fact, yes. He lived in Lincolnshire, and he's hidden from a plague 30 minutes drive nowadays in his home place, indeed, where he made lots of stuff, yes. When you looked on by the way, when you mentioned that you've been on a conference and you ask people who are mathematicians, or somebody asked, and there are only very few told that they're mathematicians, what do you think Newton would reply if he would be asked who he was?
I honestly think he probably would have said no. I've actually recently watched an interview with a very famous Barry Mazur, a mathematician, American mathematician, and he said he doesn't consider himself to be a mathematician. And I mean, you know, he is one of the greatest mathematicians of the contemporary time, you know.
How do you have a hypothesis why the mathematicians are so strict on themselves?
I think, well, I think in professional terms, they consider themselves to be mathematicians only when they come up with something fantastically clever and unique, right? But I think also on another level, I think mathematicians actually prefer not to think of themselves as professionals. They prefer to think of themselves as artists. And so if you were to ask an artist, you know, are they an artist? I don't know how many artists would call themselves artists. I think they would consider themselves to be seekers, you know, trying to find something. And I think that is really from my experience, from talking to living mathematicians.
When we just you start to talk, and you tell that in your book you choose each month you choose a person who has a birthday on that month, and it's kind of what I find in your book. It's a really nice kind of journey of a bit of unusual kind of way, because traditionally people just put like in centuries or maybe in specific field of science or mathematics. You've just chosen something which almost random, but it creates a pattern. And with Newton, I find it's quite interesting, because he is already long gone, and people still discuss when exactly he was born, right? Almost like another person a couple of thousand years before him. And with Newton, I usually say, like you said, 4th of January, and some people say Christmas. That means, in December. And I usually even say 7th of January, because in his time calendar, which was in place, in his century, that would be 4th of January. But if we keep that as Christmas, that calendar actually did not change much, and now it's already 7th of January, Christmas, on that calendar. So it's a person who has like 3 birthdays, all legitimate, and still people cannot agree.
Well, I think it would actually really amuse him, because he was obsessed, particularly about things like that. I mean, people should really look at that work he did on calendars. He was really obsessed, and he thought he had it. So it would be actually nice to ask him, but obviously that's impossible now. So maybe there is a piece of paper somewhere. I'll see whether I can whether he said, this was wrong. I was on such and such.
Yeah, and from like you mentioned, is quite remarkable that Maria Agnesi mentioned that about curve, which was like which curve. Did you find any other examples while looking on when such kind of strange kind of manifestation of unfairness, even with names in mathematics?
I have. I try not to sort of focus on the negative, but I mean that seemed to me to be pretty kind of damning, even probably unconscious kind of bias of the time, I found it very amusing. In that chapter where I speak about her, there was another man who was actually more popular internationally, or promoting Newton's mathematics to other language, to other audiences and to English-speaking audiences. And he wrote a popular book, and he sort of wrote a little book called Newton for Ladies. And it was such a patronizing little book, And you think, this person doesn't really, I mean, he understands sort of the basic principles, but he doesn't really talk about mathematics at all. It's all sort of very sort of, I don't know, Gentile kind of talk. And at this particular time, there is a woman who actually knows how it works from his own sort of, not far from where he's from. And you think, this is the times, times to change. People live with their time.
Yes. It is very, very fascinating indeed. And so now our time is approaching till the end. So we just have like 1 minute. Actually, now time elapsed. So I would like to thank you, Snezana, for coming to this math chat, and it was very interesting to have this presentation and exchange of ideas on mathematics, history, philosophy, and how it comes through past till our times. And of course, I again remind everyone about this fascinating book where one can read in more details about this pathway through the desert, which requires skills to go through the desert. I find this very poetic comparison. It's not like just a holiday type of journey, easy one. You need to be equipped. And if you are equipped, you will enjoy that. Thank you very much, Snezana. Thank you everyone who came. And of course, you can watch this video and put your comments underneath it. Thank you very much and goodbye.
Bye-bye.